playing with file descriptor and redirection. In the previous video, we've learned how to math with the shell. Let's move on to the topic. In this video, we'll show examples on how to manipulate and redirect with file descriptors. File descriptors are integers that are associated with file input and output. They keep track of opened files. The best known file descriptors are stdin, stdout, and stderr. We can even redirect the contents of one file descriptor to another. While writing scripts, we use standard input, stdin, standard output, stdout, and standard error, stderr, frequently. Redirection of an output to a file by filtering its contents is one of the essential things we need to perform. While a command outputs some text, it can be either an error or an output, non-error message. We cannot distinguish whether it is output text or an error text just by looking at it. However, we can handle them with file descriptors. We can extract text that is attached to a specific descriptor. File descriptors are integers associated with an opened file or data stream. File descriptors 0, 1, and 2 are reserved as 0, stdin, standard input, 1, stdout, standard output, 2, stderr, standard error. Let's see how to do it. Redirecting or saving output text to a file can be done as this would store the echo text in temp.txt. By truncating the file, the contents will be emptied before writing. To append text to a file, consider this as an example. You can view the contents of the file as follows. Let's see what a standard error is and how you can redirect. stderr messages are printed when commands output an error message. Consider this as an example. Here, plus is an invalid argument and hence an error is returned. Successful and unsuccessful commands. When a command returns after an error, it returns a non-zero exit status. The command returns 0 when it terminates after a successful completion. The return status can be read from special variable $?. Run echo $? Immediately after the command execution statement to print the exit status. The following command prints the stderr text to the screen rather than to a file, and because there is no stdout output, out.txt will be empty. In the following command, we redirect stderr to out.txt. You can redirect stderr exclusively to a file and stdout to another file as It is also possible to redirect stderr and stdout to a single file by converting stderr to stdout using this preferred method. Or the alternate approach. Sometimes the output may contain unnecessary information, such as debug messages. If you don't want the output terminal burdened with the stderr details, then you should redirect the stderr output to /dev/null, which removes it completely. For example, consider that we have 3 files, B1, B2 and B3. However, B1 does not have the read-write-execute permission for the user. When you need to print the contents of files starting with A, we use the cat command. Set up the test files as While displaying contents of the files using wildcards, B*, it will show an error message for file B1 as it does not have the proper read permission. Here, cat::B1, permission denied, belongs to the stderr data. We can direct the stderr data into a file, whereas stdout remains printed on a terminal. Consider the code. Take a look at the code. When redirection is performed for stderr or stdout, the redirected text flows into a file. As the text has already been redirected and has gone into the file, no text remains to flow to the next command through pipe, and it appears to the next set of command sequences through stdin. However, there is a way to redirect data to a file as well, as provide a copy of redirected data as stdin for the next set of commands. This can be done using the t command. For example, to print stdout in the terminal as well as redirect stdout into a file, the syntax for t is In this code, the stdin data is received by the t command. It writes a copy of stdout to the out.txt file and sends another copy as stdin for the next command. The cat-n command puts a line number for each line received from stdin and writes it to stdout. Examine the contents of out.txt as. Note that cat b1 permission denied does not appear because it belongs to std_air. The t command can read from std_in only. By default, the t command overwrites the file, but it can be used with appended options by providing the -a option. For example, $cat b pipe t-b out.txt pipe cat-n. Commands appear with these arguments in the format command file1 file2 or simply command file. We can use std_in as a command argument. It can be done by using the dash as the filename argument for the command, as. For example, alternatively, we can use /dev/std_in as the output file name to use std_in. Similarly, use /dev/std_er for standard error and /dev/stdout for standard output. These are special device files that correspond to std_in, std_er, and stdout. Let's see how it works. For output redirection, these operators are different. Both of them redirect text to a file, but the first one empties the file and then writes to it, whereas the latter one adds the output to the end of the existing file. When we use a redirection operator, the output won't print in the terminal, but it is directed to a file. When redirection operators are used, by default, they operate on standard output. To explicitly take a specific file descriptor, you must prefix the descriptor number to the operator. This operator is equivalent to 1. This operator, and similarly it applies for this operator. When working with errors, the std_er output is dumped into the /dev/null file. /dev/null is a special device file where any data received by the file is discarded. The null device is often known as a black hole, as all the data that goes into it is lost forever. A command that reads std_in for input can receive data in multiple ways. Also, it's possible to specify file descriptors of our own using cat and pipes, for example. Redirection from a file to a command. By using redirection, we can read data from a file as std_in as redirecting from a text block enclosed within a script. Sometimes we need to redirect a block of text as standard input. Consider a particular case where the source text is placed within the shell script. A practical usage example is writing a log file header data. It can be performed as follows. Lines that appear between cat eof log.txt and the next eof line will appear as the std_in data. Print the contents of log text as custom file descriptors. A file descriptor is an abstract indicator for accessing a file. Each file access is associated with a special number called a file descriptor. 0, 1, and 2 are reserved descriptor numbers for std_in, stdout, and std_er. We can create our own custom file descriptors using the exec command. If you are already familiar with file programming with any other programming language, you might have noticed modes for opening files. Usually, the following 3 modes are used: read mode, write with truncate mode, write with append mode. This is an operator used to read from the file to std_in. This is the operator used to write to a file with truncation. Data is written to the target file after truncating the contents. This is an operator used to write to a file by appending. Data is appended to the existing file contents, and the contents of the target file will not be lost. File descriptors can be created with one of the 3 modes. Create a file descriptor for reading a file as. We could use it this way. Now you can use file descriptor 3 with commands. For example, we will use cat <3 as. If a second read is required, we cannot reuse the file descriptor 3. It's required that we reassign the file descriptor 3 for read using exec for making second read. Create a file descriptor for writing, truncate mode, as. For example, create a file descriptor for writing, append mode, as. For example. Awesome! In this video, we have successfully learned how to play with file descriptors and redirection. Hope you enjoyed watching this video. In the next video, we'll see about arrays and associative arrays.